But again, here is the long way. I can't do the long way for 3/6. If we simplify that fraction 3/6, we get 1/2. But in terms of, say you panic on a quiz or something, just totally go blank, this can help. And it's not the most fun to write out all of those x's, and even less fun to write out 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. But what that allows us to do when we do write them out is we can see the x's canceling out. And the same thing with the y's. Y, 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 divided by y, y, y. I don't want to do that all the time. I know you don't want to do that all the time. But again, it's a technique here that maybe will allow you, 1, to get the problem correct, 2, remember the rule. So when we finish part A here, what we're left with is we're left with 1/2. And then we have 1, 2, 3 x's here left in the denominator. And 1, 2, 3 y's left in the numerator. Now, that works. If that works for you, I have no issue with that method. It just takes some time. But does anybody remember what the rule is when we really are dividing exponents? Because who really wants to write all of that stuff out? Abby? You subtract the exponents. We still, when we get to B here, divide the numbers. 20 divided by 4 is 5. But what happens is we subtract. 10 minus 2. And then we still have the y to the 8. We don't have anything to combine with y to the 8. So we're left with 5 x to the 8, 10 minus 2, y to the 8. You could have written them out and canceled them out. When we come over here to part C, same kind of thing. Simplify the fraction. Maybe that's when you want to type in 7 divided by 21 with your fraction button on your calculator. And that gives us 1/3. But I will say here, and I didn't teach it this way last year, that when we're dealing with these exponents, if you want to put them in the proper spot, you subtract bigger exponent minus smaller exponent, and you put it in the place where the bigger exponent is. So in other words here, x to the 5th, we're going to divide x cubed divided by x to the 5th. We can subtract those exponents, and because the 5 is a bigger number than the 3, we're going to end up on bottom. And it just so happens that it's going to be the same way with the y's. It's going to be y to the 8 minus. Notice that there's no exponent written on the y. It's a 1 if it's not written. So we're also going to subtract there. So we end up with 1 divided by 3 x squared y to the 7th. Casey?
So whenever wherever the biggest exponent is, that's the one
where you would subtract. Where you would subtract. That way you don't have to deal with negative exponents. That's the beauty of it. So that's just a little bit of a review of the exponents. But why do we spend this time becoming factor masters again? Well, it's really an essential skill in your mathematics life. And then it depends on what you're going to do after the fact. But in math, you really, really, really want to know how to factor. So it says simplify each of the rational expressions by factoring first. The good news here on this first one is we can factor. There's no number in front of the x squared term. So we can break apart x. Sorry, break apart x squared into x times x. And then 14. Factors of 14 are 1 and 14 and 2 and 7, will either of those combine to be 5? 2 and 7. We need to end up to have a positive 5, so this needs to be negative 2 plus 7. But then, difference between two squares. Caitlin, McKenna, difference between two squares is the one that you forgot. X squared is x and x. 4 is 2 times 2. Difference between two squares, different signs. And then lastly, it's not my best saying, but it really does work for people. Do we have anything exactly the same on the top and on the bottom? We've got an x minus 2. X minus 2 divided by x minus 2 is 1. So when we simplify this rational expression, we're left with x plus 7 divided by x plus 2. If you're a factor master, that was probably a fairly simple problem. Use the term simple loosely because for some people math is never going to be simple. But really when we look at a factoring problem, we should always start with asking ourselves, do we have a greatest common factor? On the last problem, because there was no number in front of either x squared, it didn't even enter my mind. But on this problem, we have something in front of the x squared term. Let's start with the numerator, which is the top of the fraction. Do we have anything in common? Well, will 9 go into 63? Yep. And in fact, there's an x squared and an x, which has a GCF of x. If we factor out a greatest common factor of 9x, we're left with x minus 7. 9x squared divided by 9x is x. 63 divided by 9 is 7. Down here in the denominator, we don't have to worry about a GCF, again, because there's no number in front of the x squared term, and we just factor. Factors of 7, well, there's only one set of factors for 7, 1 and 7. If we're going to combine to be 8, it needs to be negative 1 and negative 7 because we're combining to be negative 8 actually. And negative 1 times negative 7 is positive 7. And once we get this factored, we ask ourselves, do we have anything exactly the same on the top and on the bottom? The x minus 7s. And when we finish then, we end up with 9x divided by x minus 1. And we're going too fast. Problem 3. Again, we see a number in front of the x squared term and we're asking ourselves, do we have a greatest common factor? Well, we don't have a greatest common factor. And what we're going to do is we're going to slide the bottom. So we're going to take this 3 and we're going to move it over. When we move it over, we're going to multiply the 8 by the 3. And we're left with x squared plus 14x plus 24. The advantage of this method here is that there's no number in front of the x squared term. And we're left with x and x. And then we look at factors of 24 that combine to be 14. Either add to be 14 or subtract to be 14. And our factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Will any of those combine to be 14? And in fact, they're both going to be positive because 12 plus 2 is 14. Don't forget to divide. Slide, divide. And now we're going to divide by 3. When we divide by 3, we're left with x plus 4 here. But we still have 2/3. And then we're going to do bottoms up. Bring that up. So we have x plus 4. And 3x plus 2. That's all our numerator factors. The numerator being the top of the fraction. So let's look at the denominator. The denominator is x squared minus 16. Going to factor it right underneath there. Nice part is there's no number in front of the x squared term, so that makes it a little bit easier. We don't have a GCF. X squared is x and x. 16 is 4 times 4. It's the difference between two squares, different signs. To finish our simplifying process here, do we have anything exactly the same in the top and in the bottom? We've got an x plus 4 and an x plus 4. Once again, let me just tell you, x plus 4 divided by x plus 4 is 1. And we're left with 3x plus 2 divided by x minus 4. Letter D. Same process here. And it maybe is deceptively simple looking, but I will say that we do need to factor GCF in our numerator. There's a 2. When we factor out the 2, we're left with x minus 5. 2 times x is 2x. 2 times 5 is 10. We can mentally check that. Down here in the denominator, don't change anything around. It's 25 minus x squared. Here it goes again. We're going to do difference between two squares. 25 is 5 times 5. X squared is x times x. Difference between two squares, different signs. Do we have anything exactly the same in the top and in the bottom? Almost, but not quite. Now, Thomas, you took Algebra 2 2 years ago, and Blake took Algebra 2 2 years ago. There might be other people who did as well. And we did this in Algebra 2 2 years ago. But what we have here is we have x minus 5. That means x is positive and 5 is negative. Down here, this 5 minus x, 5 is positive and x is negative. We almost have the same value on top and on bottom. And we can manipulate this so that it is the same on the top and the bottom. And what we need to do is we need to get some signs changed. What do you think will allow us to get some signs changed? Abby? We have to do something though when we flip them. I know, it's such a little thing. If we make this negative 2, and actually I'm going to leave the 2 red here, but if we make it negative 2, then that's going to allow us to do what Abby said, which is flip them. We can make this negative x. Negative 2 times negative x gives us positive 2x. Negative 2 times positive 5 gives us negative 10. And down here we still have 5 minus x and 5 plus x. Now at this point, some of you can cancel out. You don't need to do the next step that I'm going to do. But just so that they all look alike, because like I said before, for some people, math is simpler than others. Keep that 2 red. -2. Let's change the order up here to 5 minus x. I didn't change anything. It's just that I wrote the subtraction second now. And then when we look at our denominator, when we ask ourselves, do we have anything exactly the same on the top and on the bottom? We've got stuff that's exactly the same on the top and the bottom. 5 minus x, 5 minus x. 5 minus x divided by 5 minus x is 1. And what we're left with then is -2 divided by 5 plus x. Like I said, a deceptively simple looking problem. But as we get close to finishing here, and I think I can get one more done, the same kind of thing. We need to factor. We're going to factor the numerator, we're going to factor the denominator, and then we're going to divide. So as we look at this one, here, x squared is x times x. Factors of 9 that are going to combine to be 6, 3 and 3, and they're both going to be minus. In our denominator, we need to ask ourselves, do we have a greatest common factor? And lots of you nodding your heads, we do. A 6. And if we factor out a 6, we're left with 3 minus x. 6 times 3 is 18. 6 times x is 6x. And do we have anything exactly the same on the top and the bottom? We don't have anything exactly the same on the top and the bottom, but we're close. So I still have time to get this one done here. The thing is, this time, and it doesn't matter which one you change. This time I'm going to change the denominator, the bottom fraction. And let's do the same thing that we did last time. Let's make this -6, which is going to change our signs. That's all we need to do. We've got the right variable and number, we just have a different sign. So that's going to make us -3. -6 times -3 is positive 18. -6 times positive x gives us -6x, which is still keeping this value equivalent here. Again, some of you here can cancel out. I am going to write it in a better format just so you can see it. With our -6, and let's change that order there so that we have x minus 3. And to finish, do we have anything exactly the same on the top and on the bottom? X minus 3. So as we wrap up here for today, and I know we still have one more example to go, are we allowed to have -6 in the denominator? So what are we going to have to do to finish this? We're going to flip everything. So if you like that word flip, that means that we're going to make x negative. We're going to make the 3 positive. And then down here, we're going to make the 6 positive as well. Last example. Remember, when we're looking at these problems, we need to ask ourselves, do we have a greatest common factor? We have a greatest common factor, in this case, of 3x. And that's going to be really helpful for us, because when we factor out the 3x, we're going to be left with x squared minus 2x plus 4. Now let's stick with the numerator here for a minute, and let's completely factor the numerator, and we can do some more, at least we think we can. But then as we look a little bit closer, we go, oh, no, we can't. The factors of 4 are 1 times 4 and 2 times 2. And there is no way that we can get 2 when we either add or subtract the numbers 1 and 4, or add and subtract the numbers 2 and 2. So we are done factoring the numerator, so we need to factor the denominator. And when we factor the denominator, what we have is a factoring cube. So remember, the cube, some people like that method of SOAP. What we're going to do is we're going to take the cube root of x cubed. Well, the cube root of x cubed is x. The cube root of 8 is 2. And here comes the signs. Same sign. And then we go opposite signs. Always positive for that word SOAP. To figure out what goes in the first position, in our second parentheses, we're going to say x cubed divided by x is x squared. And we can do the same thing for the last position in our second parentheses. 8 divided by 2 is 4. And remember, we already have the signs put in there, so that last part is we're going to take x times 2, and we get 2x. We already have the signs in there. So to finish this problem here, once again, what we have to do is we have to ask ourselves, do we have anything exactly the same in the top and in the bottom? And what we see is we have the numerators and the denominator exactly the same. So we're going to end up with 3x divided by x plus 2.